Hello students. Hello students. In today's lecture, we will learn about wave optics, and this is theory part 2. The topic which we will learn in today's lecture first is amplitude ratio, then Young's double slit experiment, and last fringe width. So these are the topics which we will cover in today's lecture. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So, topic is amplitude ratio. So, we know that intensity is directly proportional to square of amplitude. So, this is just a simple mathematical calculations. So taking square root both sides, it becomes under root intensity is directly proportional to amplitude. So, and the formula for the resultant intensity, that is IR is equal to I1 plus I2 plus 2 root of I1 I2 cos phi, where phi is the phase difference. And the for maximum intensity, phi should be 0 degree, or for the minimum, phi should be pi by 2. So there is a two condition for the maximum intensity and the minimum intensity. For the maximum intensity, phi equal to 0, and minimum intensity, phi equal to pi by 2. So I max, when you put the all the given values for max in this one in above equation, you will be get I max is equal to a root of I1 plus root I2 whole square, and let this is equation first. Similarly, I minimum, this is the minimum intensity, is equal to under root I1 minus under root I2 whole square, and let this is equation 2. So there is a two equation, we know equation first and equation second. So dividing equation first, this one, by equation second. So I max divided by I minimum is equal to under root I1 plus under root I2 whole square, and divided by under root I1 minus under root I2 whole square. So I max divided by I minimum is equal to under root I1 plus under root I2 whole square divided by under root I1 minus under root I2 whole square. So this is the case for the maximum intensity, and this is for the minimum intensity. So dividing the denominator and numerator by under root I2 in both above and below terms. So I max divided by I minimum is equal to under root I1 divided by under root I2 plus 1 divided by under root I1 divided by under root I2 minus 1 whole square. So this is just simple mathematical calculation. So I max divided by I minimum is equal to A1 divided by A2 plus 1. So we know, so intensity is directly proportional to square of amplitude. From the we write here A1 divided by A2 plus 1. Similarly, A1 divided by A2 minus 1. So I max, I minimum is equal to R1 R plus 1 divided by R minus 1 whole square. So where R is equal to A1 divided by A2, and this is the amplitude ratio. So this is just simple mathematical calculation. So amplitude ratio is A1 divided by A2. Next is Young's double slit experiment. The British physicist Thomas Young used an ingenious technique to lock the phases of waves emanating from S1 and S2. So in this diagram, there is a source, and source denoted by S, and this source spread out or generate waves, and that waves uh, emerging from this source S1 and S2. So emanating from S1 and S2, he made two pinholes, and these holes are pinholes S1 and S2, and these are very close to each other. The distance between both the holes are very close on the opaque of the screen, and the distance between screen and the source S1 and S2 is d. This is the distance as shown in this figure. Light waves spread out from S, and this S known as source, and fall on both S1 and S2. S1 and S2 then behave like two coherent sources. Listen carefully. S1 and S2 then behave like a two coherent sources because light waves coming out from S1 and S2 are derived from the same original source, and that original source is which one? The source S. An abrupt phase change in S will manifest in exactly similar phase changes in the light coming out from the S1 and S2. Thus, the two sources S1 and S2 will be locked in the phase. So, there is a diagram. The spherical waves emanating from S1 and S2 will produce interference fringes on the screen G prime. So, this is the screen is, suppose this is the screen, and G prime, this one. So, this source S denoted by S is spread out some waves like this. This is the waves, or we can say like this. This is the waves. When both are fall on a source, both fall on S1 and S2, this like this, then both the source behave like a coherent source because both the source are originating from the same source denoted by S. So these waves, this is the known as wavelets. Known as this source S1 and S2 are wavelets, or we can say is the small wave front. When both the source are suppose uh, spread out and meet at a point on the screen, so there is a two cases. First for the when the intensity of the both the waves are maximum, so there is a constructive interference, and minimum, then there is a destructive interference. So like this is a source, and this source when falls on S1 and S2, and there is a some interference fringes like this is the central fringe. B note is represents the central fringe. The distance between source S1 and from this central fringe are equal. S1, so source bright fringe, central fringe, or we can say central fringe. The distance between S1 and central fringe, and the distance between S2 and central fringe B note, both are equal. So that's why we called this is the central fringe. Clear? Bright and dark fringes are formed on the screen with central point O. So this is the central point O. B note is represent the central point O. This one. This is the central point O, behaving as the central bright fringe because the distance from S1 and this point are in the both cases are equal. Because for O the path difference is delta is 0. So path difference from S1 to central point, similarly S2 to central point are 0. So here the main point is this: the path difference when the both waves S1 and S2 meet up at the central point, in that case the path difference should be 0. For light waves reaching at point P, this is the source S1 and source S2, and this light source S1 and S2 reaching at point P, this is point P, situated at a distance x, and this is situated distance x from the origin. This is, or we can say from the central point. The path difference denoted by delta. So in that case, the path difference would be is equal to S2P minus S1P. The S2P is greater than as compared to S1P. So which is equal to XD divided by D. XD divided by D, this one. So this is the path difference when both the source waves are meet up at point P. So first case, if XD divided by D is equal to N lambda, then we get nth bright fringe. Hence position of bright fringes on the screen are given by the relation this one. So this is the position of the bright fringe on the screen. X is equal to N D lambda divided by D. This one. And case second is if XD divided by D is equal to 2n minus 1 lambda by 2, then we get nth dark fringe. Hence for the nth dark fringe, x is equal to 2n minus 1 d lambda divided by 2d. So there is a two main points. First is the position of bright fringes on the screen, and second is the position of nth dark fringe on the screen, where n is 1, 2, 3 and so on. So both the formulas are important. This one and second one is this. This is for the nth dark fringe. This one. Next is fringe width. The distance between two constructive bright and dark fringes is called fringe width and denoted by beta. Thus, beta is equal to d lambda divided by d. So, this is the distance between two consecutive bright and dark fringes. This one, where d is the, this is the distance from the source and the screen, and lambda wavelength, and small d is the, this is the distance between the sources. So, here there is a two condition. First is for the constructive bright fringe, and second is the for the destructive bright fringe. When the intensity, maximum intensity, both when the source S1 and source S2 both are generates maximum intensity and meet up at a point on the screen. So in that case, there is a constructive interference, and when source S1 and S2 spread out, we can say minimum intensity, in that case there is a destructive interference. So both the interference are important for the exams. And the for a given arrangement, this arrangement as S1 S2 screen and fringes is, we can say it is constant, and that is all the fringes are uniformly spaced. Moreover, fringes width beta is directly proportional to d, capital D, and beta is directly proportional to lambda, known as wavelength, and beta is inversely proportional to d. This is the distance between the both the source. So from this formula, I hope all the points are clear. First, second and third. So this is the important for the exams. This relation and this, all three relation comes from the this equation. This one. This is clear.
Hello students, in today's lecture we will solve some practice question based on wave optics, and this is practice question part 2. In today's lecture we will cover practice question 6 to 10. So topic is wave optics. Question is, in Young's double slit experiment, the intensity at a point where the path difference is lambda by 6, lambda being the wavelength of the light used, is I. If I naught denotes the maximum intensity, I divided by I naught is equal to what? This is AIEEE 2007 question. Given options, option A is 1 divided by root 2, option B is root 3 divided by 2, option C is 1 by 2, and option D is 3 by 4. So which option is correct? Option A, option B, option C, or option D? You have some time to solve this question. After that, we will provide the solution of this question. So, in Young's double slit experiment, the intensity at a point where the path difference is lambda by 6, lambda being the wavelength of the light used, is I. So, I is the intensity. If I naught denotes the maximum intensity, I divided by I naught is equal to what? So, we have to find the I divided by I. The phase difference is related to path difference, and this is given by the formula, and the formula is this one. Phase difference is equal to 2 pi divided by lambda multiplied by path difference, and this is important formula, and phase difference is denoted by symbol phi. So phi equal to 2 pi divided by lambda multiplied by path difference, and path difference is lambda by 6, which is given in this question. This is path difference. So phi after calculating becomes pi by 3. In a Young's double slit experiment, the intensity I at any point on the screen can be expressed as this one. I is equal to I max cos square phi by 2. So this is the intensity formula, comes from the Young's double slit experiment. So we have to find the I divided by I naught. So I divided by I max is equal to cos square phi by 2. This is the simple calculation. I divided by I max is equal to cos square phi by 2. We know some value. So I max is equal to I naught. So cos square phi is pi by 3. So pi by 6. And we know the cos pi by 6 is equal to root 3 by 2. And after squaring, cos pi by 6, which is equal to root 3 by 2, becomes 3 by 4. So I divided by I naught is equal to root 3 by 4. This one. So correct option is option D. Next question. In Young's double slit experiment, the intensity at a point is 1/4 of the maximum intensity. Angular position of this point is what? And this is AIEEE 2005 question. So according to the question, suppose at this point the intensity is maximum. At a point at this point intensity is 1/4 of the maximum intensity. So what will be the angular position of this point? Given options, option A is sine inverse lambda by d, option B is sine inverse lambda divided by 2d, Option C is sine inverse lambda divided by 3d. Option D is sine inverse lambda divided by 4d. So which option is correct? Option A, option B, option C, or option D? You have some time to solve this question. After that, we will provide the solution of this question. So in young double slit experiment, the intensity at a point is 1/4 of maximum intensity, and this is the important point. So question asked about the angular position of this point is what? So we know the relation from the Young's double slit experiment, I is equal to I max cos square phi by 2, where phi is the phase difference. So we have to find the angular position, and given at a point, intensity at a point is 1/4 of maximum intensity. So suppose the intensity at a point is I, or according to question it is 1/4 of maximum. So maximum is denoted by I max, and the 1/4 is I max divided by 4, which is equal to I max cos square phi by 2. So I max cancel out. Cos phi by 2 is equal to 1 by 2, or phi by 2 is equal to pi by 3. So phi becomes 2 pi divided by 3, this one. And phi is equal to 2 pi divided by lambda multiplied by delta x. So this is the relation between the phase difference and path difference. And let this is equation first. This is equation first, where delta x is equal to d sine theta. Substituting in equation first, we get sine theta is equal to lambda divided by 3d. When you substitute delta x in equation first, which is this one, phi is equal to 2 pi divided by lambda multiplied by delta x, then sine theta is equal to lambda divided by 3d. So theta is equal to sine inverse lambda divided by 3d. So this is the correct answer. So correct option is option C. Next question. The first diffraction minimum due to single slit diffraction is theta for a light of wavelength 5000 angstrom. Angstrom means 10 raised to the power minus 10. If the width of slit is 1 into 10 raised to the power minus 4 centimeter, then the value of theta is what? So in this question asks about the value of theta is what? Where width of the slit is 1 into 10 raised to the power minus 4 centimeter. Given options, option A is 30 centimeter, option B is 45 cent, sorry. So the first diffraction minimum due to single slit diffraction is theta for a light wavelength 5000 angstrom. If the width of slit is 1 into 10 raised to the power minus 4 centimeter, then the value of theta is what? Which is asked in this question. So we know x is equal to d lambda divided by small d. So this is this one. So x divided by d is equal to lambda by d. So this is the simple mathematical terms. So we have to find the theta. So d is equal to lambda divided by sine theta. So sine theta is equal to lambda divided by d. So lambda and d, which is given in this question, lambda is 5000 angstrom. So 5000 multiplied by 10 raised to the power minus 10, and d is 10 raised to the power minus 2 multiplied by 10 raised to the power minus 4. So this is convert into centimeter to meter, this one. So we know after calculation 0.5 is equal to sine 30 degree. The value of sine 30 is 1 by 2. It becomes 0.5. So theta is equal to 30 degree, this one. So correct option is option A. Next question. A parallel monochromatic beam of light is incident normally on a narrow slit. A diffraction pattern is formed on the screen placed perpendicular to the direction of incident beam. At the first maximum of the diffraction pattern, the phase difference between the rays coming from the edges of the slit is what? So in this question asks about the phase difference between the rays coming from the edges of the slit is what? So given options, option is 0, option B is pi by 2, option C is pi, and option D is 2 pi. So which option is correct? Option A, option B, option C, or option D? You have some time to solve this question. After that, we will provide the solution of this question. A parallel monochromatic beam of light is incident normally on a narrow slit. A diffraction pattern is formed on a screen placed perpendicular to the direction of incident beam. At the first maximum of the diffraction pattern, the phase difference between the rays coming from the edges of the slit is what? So we know the phase difference, which is denoted by phi, is equal to phi equal to 2 pi divided by lambda multiplied by d sine theta. This one. This is the formula to calculate the phase difference, where d is the slit width. The first minima of the diffraction pattern occurs at sine theta is equal to lambda divided by d. This one. So phi equal to 2 pi divided by lambda. So d divided by sine lambda divided by d. This comes from this relation. Sine theta is equal to lambda divided by d. So substitute the sine theta with this one, lambda divided by d. So after calculating this term, you will be get phi equal to 2 pi. So the phase difference between the rays coming from the edges of the slit is 2 pi. So this is the correct answer. So correct option is option D. Next question. In a Fraunhofer diffraction experiment at a single slit using a light of wavelength 400 nanometer, the first minimum is formed at the angle of 30 degree. The direction theta of the first secondary maximum is given by what? Given options. Option A is sine inverse 2 by 3. Option B is sine inverse 3 by 4. Option C is sine inverse 1 by 4. And option D is sine inverse 2 by 3. So which option is correct? Option A, option B, option C, or option D? You have some time to solve this question. After that, we will provide the solution of this question. So in a Fraunhofer diffraction experiment at a single slit using the light of wavelength 400 nanometer, the first minimum is formed at an angle 30 degree. The direction theta of the first secondary maximum is given by what, which is asked in this question. So we know for the first diffraction minimum, a sine theta is equal to lambda, this one. So a equal to lambda divided by sine theta. For secondary maximum, a sine theta prime is equal to 3 lambda divided by 2. So sine theta prime is equal to 3 lambda divided by 2, and a becomes 1 multiplied by 1 divided by lambda. So this is the simple mathematical calculation, this one. So 3 lambda by 2 multiplied by sine theta divided by lambda. So sine theta is equal to this one. A is equal to lambda divided by sine theta. So a here, so sine theta divided by lambda is the value of a. So here when you put the value, so lambda and sine theta divided by lambda, this one. So this is the simple mathematical calculation. So 3 by 2 multiplied by sine 30 degree, which is given in this question, angle is of 30 degree. So after calculation, this is equal to 3 by 4. So theta prime is equal to sine inverse 3 by 4. Clear? Theta prime is equal to sine inverse 3 by 4. So this is the correct answer. So correct option is option B.